Lesson 6-1, Solve Systems of Linear Equations Graphically. So in this video, we're going to show one way of solving a system of linear equations. And I'll be graphing not only on a coordinate plane, but also with your graphing calculator. Now, a system of linear equations is a set of two or more equations that have variables in common. The solution of a system of equations is a set of values for the variables that make each equation in the system true. So in other words, we want to find out where these two lines meet. And the place that the two lines cross is the solution to the system. Now the solution set can be described in different ways. Here are the ways you can describe them. So it's consistent and independent if there's exactly one solution. That means the two lines cross in exactly one spot, and that intersection point is the solution. And we normally write the solution as an ordered pair. Consistent and dependent means there are infinitely many solutions because they are exactly the same line. Now, they may not look like it when you first look at the equations, but when you simplify them, they will, and put them in slope-intercept form, you will see that they are the exact same line. And then inconsistent would mean the lines do not cross, and the reason why they do not cross is because they are parallel lines, and you know that parallel lines have the same slopes. Therefore, this would be no solution. So and then now when it comes to graphing, how do you graph these? You can either create a table of values, input x values in there, come up with your y values. You could use the slope and the y-intercept if it's in slope-intercept form, or you can use your graphing calculator to graph it, or you can use the graphing calculator to create the table of values to plot on your coordinate plane. So let's take a look at our first example. Max challenges his brother Eric to a race on the way to football practice. He gives Eric a 20-yard head start. If Max runs 6 yards per second and Eric runs 4 yards per second, how long will it take Max to catch up to Eric? So we are comparing Max. So Max runs at 6 yards per second, but he doesn't get a head start. So his equation is going to be y equals 6x. Now Eric, on the other hand, he gets a 20-yard head start and he runs at 4 yards per second. So that would be y is equal to 4x plus 20. Now on my coordinate plane that I have here, I would have to renumber the axes in order to fit this on here. So in order to do this one, I'm going to use my graphing calculator. So I hit the y equals button, and the first one is 6x, so I hit 6 and the x. And then Eric, I have 4x plus 20. So those are my two equations. Now if I hit graph, you can see that they both cross somewhere around here. Now if I went to zoom and go back to standard form, this is what yours normally would look like. Now they look like they could be parallel, but they do cross way up here. So I would have to change my window setting. Now since there's dealing with time and distance, I can't have negative numbers. So the x minimum is talking about the time. That's going to be 0. I can't go to the negatives. The maximum number of time, I don't know what the maximum time is going to be, so I'm going to just say 20. And I'm going to count these by, let's just say 5. That y minimum, the distance, I'm going to say is 0. The maximum, I don't know how far they're going to run, so let's just say 200 yards. And here we're going to count by, we'll count by tens. Now if I hit graph, there's Max, here's Eric, they cross somewhere right here. Now there's two ways you can do this. If I hit second graph, I can see the table of values, and I want to see where do the y values have the same number. So if I keep scrolling down, this is where they both have the same y value. So at 60 yards, that's going to be after 10 seconds. So the answer to this one, Max will catch up to Eric at 10 seconds. Now the other way you can do that, if I was just looking at the graph, I can hit second trace, and I'm looking at the intersection point number 5. And then it's going to say first curve, and it's highlighting the first equation. So if I hit enter, it's now going to say second curve, hit enter, that goes to the second equation, or second graph. Guess means now I know which two lines. Hit enter a third time, and it tells me the intersection point is at 1060, which means at 10 seconds, they will both meet or catch up at 60 yards. Next, solve this system by graphing. Now going back to this other one, since this one gave me an exact point, this would be considered consistent and independent. So two lines cross in one exact spot. Next, x is equal to 2, so I know the point is here. It's going to be a vertical line. The other one, I have 5x plus 2y equals 6. I'm going to subtract 5x on both sides. And then I have 2y is equal to negative 5x plus 6 divided by 2. This equation is going to be y equals negative 5 halves x plus 3. So I have a point at 3 on the y-axis. Down 5, 1, 2, 3, 4, 5. To the right 2, 1, 2. So it's going to cross down here. And the point that they're going to cross will be 2, negative 1. And because it crosses in exactly one spot, this would be consistent and independent. Next, here I got this one here. I can plot that one, y equals negative x plus 2. So put a point at 2 on the y-axis. It goes down. So that would be that line there. The other one, if I subtract 2x, I now have 3y equals a negative 2x plus 2 divided by 3. Now I have y is equal to negative 2/3 x plus 2/3. Now I don't like doing graphing with the fractions in there, especially my y-intercept. So I'm going to go to my graph here, graphing calculator, and I'm going to put it in here. So we got negative 2/3 x plus 2/3. And I'm going to use the table feature, so second graph. And I want to look for integers. So I have 4, negative 2. So I want to plot a point at 4, negative 2. Which would be right here. And then go back, find another one. I have 7, negative 4. So 7, negative 4. Will be right here. So now if I draw my line, looks something like that. But this is the point that they cross. That's going to be at 4, negative 2. So this would be consistent and independent. Next, I have y equals 4, so it crosses the y-axis at 4. The other one, subtract 2x, so I had negative y equals negative 2x minus 8. Divide by negative 1, and I have y equals 2x plus 8. So I'll plot this one, positive 8. This one's up 2 over 1, or I go down 2 to the left 1. So the point on this one would be -2, +4. So this one would be consistent and independent because they cross in exactly one spot. Next, graph these. So first one is going to be y is equal to subtract x, so -x plus 4. This another one is y equals -x minus 2. So -x plus 4 is going to go here. And it's going to go down like this. And the other one crosses at -2 and also going to go down at a negative slope. So this one's going to look like this. The lines are parallel. If you look at the slopes, the slopes are the same. So this would be considered inconsistent. Inconsistent because they don't cross. It's not independent or dependent. You can only use those if they cross, because independent means they cross once, dependent means they cross many times. So this one would be a no solution because they never cross. There is no x value where they cross. Next, here I'm going to divide everything by 4. I'm going to say, actually, let me get this y by itself. So it would be -4y equaling a -6x minus 36. Divide everything by -4. That leaves us with y is equal to 3/2 x plus 9. And the other one, divide everything by 6, and I'm left with y is equal to 3/2 x minus 9. Now the slopes are the same, so they're going to have, they are going to be parallel, but let's graph it. Point at -9 goes up 3, 1, 2, 3, to the right 2. So this line looks like this. The other one, the red one, plot at 9, down 3, to the right 2. This one's going to go up like this. They are parallel, no solution. We would consider this one inconsistent. Next, solve this one by graphing. So I got -10y equals -6x plus or minus 20 divided by -10. We now have y is equal to, divided by 2/2, that would be 3/5 x plus 2. And the other one is going to be y is equal to 3/5 x plus 2. So let's graph that one. So +2. You'll notice that these are the same equations. So it's going to be the same line. So up 3, 1, 2, 3 over 2. It's going to look like here. The blue one's going to be right on top of it. So these would be considered consistent and dependent. And we would say many solutions. Next, here we got 2 more equations. I'm going to add 10 to both sides. And then divide by 2. So that's going to be y is equal to -3/10 x plus 5. And the other one is going to be, divide that by -12, which would be y is equal to 15 divided by -12. Gives us -5/4. x, and negative 60 divided by negative 12 is a positive 5. So if I graph those, I got point at positive 5, down 3 to the right 10, be here, or up 3 to the left 10, which would be here. So there's one line, and then the red one here, positive 5, negative 5/4, so they'd be down 5 to the right 4, or up 5 to the left 4. This one goes down this direction. You can see that they cross at the y-intercept exactly one spot. So this one would be at 0, 5. We consider this one consistent and independent. And our last one we're going to do on our calculator. But let's come up with our equations first. So Nassim wants to compare the membership costs of two gyms. Gym 1 requires that they buy a $120 membership fee plus charge $20 per month. So that's 20x plus 120. And Gym 2 is going to be, has no membership fee, but they charge $30 a month. So that's 30x. So if we go to our calculator, turn it on, go to our y equals, clear what we have. Gym 1 is 20x plus 120, and the other gym is 30x. Now I might change my Windows setting. Let's just keep it as is to see where, if they do cross, I need to extend the y maximum. So let's make this 500 and count by 100. Now if we hit graph, hit second trace, number 5 intersect, first line enter, second line enter, guess, enter, 12, and then 360. So in month 12, they will pay the same amount, which will be $360. So that is our lesson on solving systems of equation by graphing.